Welcome to the SNMP Southbound plugin video series. In this part, we'll take a look at the MIB to YANG conversion process. We will present a translated YANG model and discuss the differences between the two. To do so, we will use the SMI to YANG command line application for offline conversion. But first, let's take a quick look at MD-SAL and the need for such conversion. MD-SAL, the core component for ODL, is built around the YANG modeling language, which is used to model data structures and their representation by so-called normalized nodes. This provides a unified way of communication between applications, or as we will call it, the service abstraction layer. As ODL-SAL is based on YANG models, it is called MD-SAL, Model-Driven Service Abstraction Layer. To fully integrate an SNMP device into MD-SAL, we need to have its YANG model available. To ease the explanation of what a YANG model actually is and how it relates to a MIB, we are going to use a fact diagram. A fact diagram is composed of facts represented by arrows and terms represented by boxes. We will use terms in place of system parts and components and facts to describe their relationships. Let's start from the top. On the top, we have an ODL distribution comprised of a set of features that cooperate and communicate together. MD-SAL, providing a variety of services, is one of those features. Also, there's our SNMP Southbound plugin, which can be used as a feature or as an ordinary application. Southbound is a generic term indicating that a feature communicates with physical devices. In our case, any SNMP-capable network elements. The topology SNMP box represents one topology element residing inside the network topology container. The name of the topology is of course configurable. As mentioned earlier, network topology is modeling or defined in YANG language. Therefore, we can store or retrieve this data from MD-SAL. This topology is used to manage SNMP network elements. To connect to an SNMP device, we have to create a node in it. This node has to contain all the parameters required for connecting to a given device. In our case, it's an IP address and a set of models supported by the device. Another service we are interacting with is the DOM mount point service. It is used to keep track of mount points based on their identifiers. The next one is the mount point, which is basically a set of services used for accessing a device, performing read and write transactions, and listening to traps sent from a device. The mount point is created and managed by SSB. The mount point represents a device from the data or content access point of view, while a node in topology SNMP represents a device from the management point of view. That is, how to connect to this device or its status, whether it is reachable or not. The next part, and one of two most important for us, is the SNMP Southbound plugin. Its purpose is to listen to management requests, physically communicate with the device, and translate all data from and to normalized nodes. Normalized nodes are DOM data objects whose structure is based on the YANG model, and this is the core communication concept in the ODL's SAL layer. The second part that is important for us is the SMI to YANG converter, which is used to translate MIB models to YANG models. The last live component is, of course, our SNMP-capable network element. In this diagram, we can see how it is all related and, in most cases, also interconnected. We are going to focus on one specific part, and that is the relation between the MIB model, YANG model, device, and SNMP Southbound plugin. SNMP devices provide sets of configuration or status information based on the MIB model. For example, if the device wants to provide information about interfaces, it probably implements the if-MIB model. And now the SMI to YANG converter comes into play, which translates this to a YANG model. Because the whole of ODL and MD-SAL is built on top of a YANG model, this translation enables access to the SNMP device content or data in ODL native way, which are normalized modes. This is the most important part of SSB, and thanks to that, we can add any SNMP network element just by providing MIB models that this network element supports. SNMP devices communicate through the network using PDUs, so another big part of work is done in SSB plugin, which translates these PDUs to normalized nodes and back based on the translated YANG model. This way, we have a model-based concept of adding support for SNMP network elements, so we can freely access any kind of SNMP device while we have a set of its implemented MIB models. We are going to talk a little about basic translation flow. Firstly, we need our MIB model we want to translate, and another thing we need are the MIB models that this model imports. These are also called secondary MIB files. Basically, we have a pool of MIB files from which one is the primary MIB, which we want to translate, and the rest are imports required by primary MIBs. This information is required by the SMI to YANG converter to successfully convert MIB models. Before the command line tool demonstration, we will firstly take a look at the MIB model and its YANG equivalent, and we will talk a little bit about the main differences between them, which are quite huge. Translation from a MIB to a YANG model is strictly based on RFC 6643, which specifies how to translate SMI version 2 to YANG. SMI is shortcut for Structure of Management Information, and it defines the rules of how to describe management objects, which is our MIB model. So the MIB model is a collection of management objects which represent some content in our network element. Let's take a better look at our models. On the left side is the MIB model, and on the right side is the translated YANG model. The main difference is in the structuring of the model. The YANG model is composed of nested statements. This is easy to read and understand in comparison to the MIB file. We can't even tell what is the OID for the particular element in the MIB file because it is not provided as a whole, but instead in parts. So to know the whole OID, we need some kind of software that does this for us. In the YANG model, we have this information already available for every container, leaf or list. But OID doesn't concern us at all because we don't use it anymore, and this is the huge advantage of the YANG model. This is true especially when we need to work with indexes in lists. To address container, list or leaf in the YANG model, we are using a path to this element, and this path is constructed by putting together the names of nested statements plus some extra information like model name and so on. For example, to access the whole IF table, our path will be if-MIB, IF table. We can also access the specific interface by providing its index, and it will look like this: if-MIB, if-table, if-entry, 1. It's natural, and with a little practice, also easy. Now we are going to show you the command line tool, or we can also call it an application. The purpose of this application is to translate MIB models to YANG models. If we in any case require offline translation, this is one way to do it. This tool is written in Java, so we are running it using Java tools. This is how we can run it. If we run it without required parameters, nothing happens except showing help information. The application requires at least 3 parameters. The first is a directory containing MIB files. This includes primary and secondary MIBs. The second parameter is the directory where we want to save our translated files, and the third and consecutive parameters are primary MIB files. These are MIBs we want to translate. That's everything for parameters. In this directory are our MIB files we are going to translate. Now we can run the tool with the correct parameters. After running the tool, we can see an output from it. In the output is a list of process MIB files and also a report written on YANG models. Let's take a brief look into the directory with YANG models. The output also includes IETF core imports, and this is our translated if-MIB YANG model. Thank you for your time. In the next video, we are going to take a look at the SMI2 YANG Maven plugin, which is part of the SNMP Southbound plugin. Have a nice day.